Hello everyone, welcome back to the second lecture of redox reaction. In the first lecture, we have talked about how we can determine redox reaction in terms of oxygen atom. In the second lecture, we are going to define a redox reaction from the terms of oxidation number. Okay, so in oxidation, my oxidation number gonna increase. My oxidation number gonna decrease when I am undergoing reduction. Before we move on, we need to learn how do we find oxidation number. Okay, with that, let's bring up some example for us to learn. There is 8 principle, kind of like a guideline in order to determine the oxidation number. Okay, bear with me. All right, I will try my best to make this less painful. Okay, so the first one, oxidation number of elements always equal to 0. So an element, it's a pure substance that consists of only one type of atom. Okay, for example, you have your sodium, you have your carbon, you have your oxygen, and you have your chlorine. Okay, they are all have oxidation number of 0. Okay, that's it, easy. Whenever I'm an atom, molecule of same element, right? The oxidation number is equal to 0. Okay, number 2. Okay, this is the first guideline. I'm just going to underline here. The second one, oxidation number for monoatomic. Okay, monoatomic stands for atom with a single ion. Okay, single ion atom. Okay, single atom ion. Okay, it's equal to the number of charge. I'm just gonna put charge. For example, when I have my Cu2 plus, my oxidation number is +2. If I have my bromide ion, the oxidation number is -1. When I have my aluminum ion, my oxidation number is +3. Done, done. Oh, this is easy. This is very fast. Okay, the third guideline is oxidation number for group 1, group 2, group 13. They are +1, +2, and +3. And the third one. Okay, the next one. Okay, this is very important. For the fourth guideline, this is very important. Let me zoom in. It says the sum of oxidation number of the elements in a compound is equal to 0. Let's have a look here. Let's say I have a compound, magnesium oxide. Magnesium, we know magnesium is located in group 2. Therefore, magnesium must have oxidation number of +2. Let's say I want to find the oxidation number of oxygen. I can denote oxygen oxidation number as X equal to the sum must be 0. I'm going to put the 0 here. Therefore, I can find my X, which is my oxidation for oxygen, which is equal to -2. So this is the concept behind a sum of oxidation number equal to 0. Let us try one more example. I have my NaCl, sodium chloride. So for sodium, I know it is located in group 1. So it is a +1. I put a plus here. Chlorine, which is located at group 17. I know that it must be -1, but then I denote it with X because I want to find the oxidation number of chloride ion. Equate it to 0, my X will be -1. There we go. The concept here is I have my +2 plus with -2. I'm gonna get 0. The sum of the oxidation number in a compound is equal to 0. So this is the concept here. Okay, with that, let's look at our earlier example. So in the earlier example, we have our, let me just pull out this chemical reaction here. Let's go back to the earlier example. In the earlier example, I have my magnesium react with carbon dioxide. And then it produces magnesium oxide and carbon. If I were to balance this out, I'm gonna put a 2 here and 2 right here. Okay, I think we're all balanced, all good. So let's look at the oxidation, change of oxidation number. Okay, so right here, magnesium, it is atom. Therefore, the oxidation number, it is 0. Okay, for carbon, how do I find oxidation number of carbon? Okay, remember, this is a compound. Let's say I want to find the oxidation number of carbon. I'm going to assign it as X. Most of the time, oxygen will have oxidation number of -2. Since I have 2 oxygen atoms, I'm going to put 2 in front, and then I'm going to put a -2 equals 0. So when I find my X, I'm going to get +4. Turns out, carbon, it has an oxidation number of +4. Oxygen, just by itself, it is -2. Okay, and then I can do the same thing here. Magnesium gonna have oxidation number of +2. Oxygen will have oxidation number of -2. Carbon, on the other hand, will have oxidation number of 0 because it is now an atom, an element right here. Okay, so what happened, we can see for magnesium, the oxidation number changed from 0 to +2. For carbon, the oxidation number changed from +4 to 0. When I have increase in oxidation number, I say it is oxidation. When I have decrease in oxidation number, I say reduction take place. Magnesium is experiencing oxidation. Carbon is experiencing reduction. This is the exact species that undergo reduction. There we go. This is in terms of oxidation number. Okay, by calculating the oxidation number, we can find out whether oxidation or reduction has happened. Let's look at oxygen. So for oxygen, if you see the oxidation number, 8 remains from -2 to -2. So nothing happened to my oxygen. This is a spectator ion. Let me stop here for now. We will continue later on.